So let us move to the next question. Eighth one, a spy. Who is that? A spy report about a suspected car reads as follows. Some suspected car is there. The car moved 2 kilometers towards east. How much is that? 2 kilometers towards east means I wrote it as 2 I cap. Made a perpendicular left turn, something like this. The car traveled 2 kilometers along positive x-axis like this and made a perpendicular left turn. Right means this way. For this person, right means downward, left means upward. So, perpendicularly left turn. Made a perpendicular left turn, ran for 500 meters. How much he traveled? Only 500 meters. This is kilometers, that is only meters, half kilometer. Right turn, ran for 1 second. So, let me repeat the question. A spy report about a suspected car as follows. The car moved 2 kilometers towards east, made a perpendicular left turn, ran for 500 meters, again made a perpendicular right turn. For this person, left means here, right means here. Perpendicular right turn means something like this. So, for made a perpendicular right turn and again ran for 4 kilometers and finally stopped. Find the displacement of the car. So, ask to find out the displacement of the car. What is the displacement of the car? Displacement of the car is this from here to here. The initial position to the final position. That indicates your displacement of the car. So, in order to find out this, you have two methods. Okay. So, directly let us go with the second method only, representing IJK vectors only. That gives a proper value. So, what is the total displacement? In order to find the total displacement of the car, first of all, how much he was traveling? 2 kilometers towards east. That means 2 I cap. 500 meters towards north. So, 500 meters is nothing but 500 by 1000 kilometers. How much is that? 1 by 2 kilometers. So, half kilometers north direction plus half kilometer north upward is taken as J cap. And ran for 4 kilometers in that direction. 4 kilometers which direction? Again positive. So, plus 4 I cap. So, what is the total displacement? Here it is 2 I cap and 4 I cap, 6 I cap plus half J cap. So, this is your displacement vector. So, no doubt it lies in the IJ, northeast direction, maybe something like that. But you have to find out the magnitude. Magnitude of the displacement vector is nothing but root over 6 square plus half square. And this is nothing but 36 plus 1 by 4. And 36 plus 1 by 4 is nothing but 1 by 4 is 0.25. 36 plus 0.25 is 36.25 under root. So, magnitude of the displacement vector is 6 square is 36, 7 square is 49. So, it's nearly equals to 6 square. Hence, so approximately it is something like 6 point. So, 6 point, it's something like very near to 6. So, 6.02 kilometer. Clearly. So, what is the answer, children? So, it's nearly approximately equals to 6.02 kilometers. Now, you are also asked to find out the direction. Direction means, suppose if you were given an equation of form xi cap plus yj cap, then its direction is given by tan theta equals to coefficient of y direction to the coefficient of x direction. That is y upon x. How much is that? Y upon x. Now, what is the equation? We got it as children. Displacement vector is s bar is equals to 6 I cap plus half j cap. Therefore, tan theta for this is equals to Y coefficient half 1 by 2 upon 6. It's nothing but 1 by 12. If tan theta equals to 1 by 12, then no doubt theta is equals to tan inverse of 1 by 12. Theta equals to tan inverse of 1 by 12. Hence, the correct option must be option 2. So, displacement is magnitude of the displacement is 6.02 kilometers, whereas the direction is indicated by tan inverse of 1 by 12. So children, moving with the next one, that is 9th question. A carom board 4 feet cross 4 feet square has the queen at the center. So this space is not sufficient. Let me move to the second page to visualize this carefully. So what is given is a carom board is being given whose cross section is 4 cross 4. So 4 feet each was given. It is in the form of a square. A carom board 4 feet cross 4 feet square has the queen at the center. So what is that? It has a square queen at the center. So carom board 4 cross 4 feet square has the queen at the center. The queen hit by a striker moves to the front edge and rebounds and goes in the hole, being the striking line. So this must be your striking line. So these are the 4 lines from which it is being striked. Striker goes and hits and something like this. So this is your striking line and this is your front line. Okay. Well, so what else is given? And you have 4 holes here. 1, 2, 3 and 4. Okay. Well, so let us visualize. A carom board has the queen at the center. The queen hit by the striker moves to the front edge, rebounds and goes in the hole, being the striking line. So this is your striking line. So whenever it was a hit with a striker, this goes to the front and again this is the striking line. So after hitting forward, front line comes and falls in the hole, going like this and falls. Is that point clear, children? So when it was hit at certain angle, touches the front edge, again rebounds back and falls into that hole, which is in the striking line. The magnitude of the displacement of the queen from the center to the front edge is, where is the center? Here is your center. So what they are asking is this initially which was here, after striking at this position falls here. So this is the displacement, goes like this, again goes like this. So you are now asked to find out the displacement of the queen from the center to the front edge. Where is the center? This must be your center. Where is the front edge? This. So you are asked to find out this particular displacement. So let me name this displacement as some S. So you have to find out this displacement S. Is that concept clear, children? Do you have any guesses how to solve this numerical? Yes, I am here to explain. This is not going straight, some particular direction. But no doubt this is at the center position. So what we say is, let us try to visualize this properly. So let us divide this into 4 equal parts. Okay. If you divide this into 4 equal parts, no doubt when it is been hit, it moves forward and something like that. But it was hit in the corner position. So if the total length of the carom board happens to be 4 feet, then this must be 2 feet and this must be 2 feet. So this portion is also 2 feet. Everywhere you have 2 portion, 2, 2, 2, 2. Everywhere it is divided into 2. If total from here to here it is 2, then how much is this and how much is this? Confused? So what I do is, as the value from here to here, as we know that it is 2 feet, from here to here, let us consider this as some x. So this must be 2 minus x. So this must be 2 minus x. This portion is x and the remaining is 2 minus x. If you observe this carefully, let us consider a bisector. These two parallel lines and this is an intersecting line. Okay, so in this case, the angle, if you observe, it's a bit tricky question, children. Concentrate careful. Nothing I did. I took the carom board 4 cross 4 feet, center position. I divided the carom board into 4 parts. So each part will be here. Here it is 2. Here it is also 2. Here also 2 and here also 2. So like that I have divided itself. Half, perpendicular lines I drawn. So if total happens to be 10, at the striking point, if I consider this as x, then this, the remaining must be equals to 2 minus x. So let us consider this portion as theta. This perpendicular line divides into 2 equal parts. The perpendicular lines divides the whole region into 2 equal parts. Yes. From the complete right angle triangle, this portion if you consider, only this portion of the right angle triangle you consider, can you tell me tan theta? What is the value of tan theta, children? The value of tan theta from the figure is opposite by adjacent side. What is this particular length? It is nothing but x. This portion is nothing but x upon adjacent side. What is this adjacent side? This total length. How much is this total length? Complete it is 4 feet means only half portion it must be 2 feet. So x by 2. In this small triangle, tan theta equals to opposite it is x, adjacent it is 2, x by 2. The same theta over here, if you consider this complete picture, again we can observe one more right angle triangle here, children. In this right angle triangle, if you observe this theta, what is that value of theta? So here also we have tan theta in this big triangle is opposite by adjacent. What is this portion? Opposite. Angle opposite is this total. But how much is that? It is no doubt its value equals to 2 minus x. 2 minus x upon opposite by adjacent. Adjacent is from here to here. This total length. The total length is one side of the complete carom board. How much is that? 4 feet. So here also tan theta, we consider it as x by 2. There we consider tan theta is 2 minus x by 4. So LHS is equal. So you can equate RHS. So from equation 1 and 2, we can consider that x by 2 is equals to 2 minus x by 4. Cross multiplying and simplifying, children, we have 4x must be equals to 4 minus 2x. Bringing the 2x the other side, 4x plus 2x is 6x equals to 4, or x is equals to 4 upon 6 is found to be 2 by 3. X is found to be from here to here. What is the distance, children? 2 by 3. But are you asked to find the value of x? No. You are asked to find the value of the displacement vector, this portion. So from the figure, the displacement vector, yes, can be written as this portion is equals to sum of the squares equals to this square. Pythagoras theorem. In this right angle triangle, applying Pythagoras theorem, s square is equals to, this length is x square plus this length, this is 2 square. So s is equals to, what is the value of x? X just now we calculated as 2 by 3. So 2 by 3 whole square plus 2 square is 4, or s is found to be 4 by 9 plus 4. Under root. Hence, taking 4 and 9 as, so taking 4 as common, we have, this indicates 2 root over 4 is taken, 1 by 9 plus 1, this is nothing but 10 by 9, or S is equals to 2 by 3 times of root 10. How much is that? The value of the displacement from the center to the front edge, the value of S is found to be 2 by 3 times of root 10. So let us check out the question once again. The magnitude of the displacement of the queen from the center to the front edge is found to be 2 by 3 root 10 feet. 2 by 3 root 10 feet. I hope the concept is clear, children. So what I considered is, so first of all, at this position, I consider this position as x and remaining portion as 2 minus x. The second case, I tried finding out, I draw the perpendicular line here, intersecting line. So for this intersecting line, it acts as a bisector, divides the complete angle into 2 equal ratios. If this happens to be theta, this is also theta. Smaller triangle, I consider tan theta. Bigger triangle also, I consider tan theta. Smaller triangle, tan theta equals to opposite by adjacent side. This is x upon 2. Bigger triangle, tan theta equals to opposite by adjacent side, 2 minus x upon 4. So, equating these two, I got the value of x. Once I got the value of x, I found the value of the displacement vector. S is equals to, applying Pythagoras theorem, root over x square plus 2 square. Substituting the value of x as 2 by 3, I found the value of the displacement vector from center to the front edge as 2 by 3 root 10 feet. So, first option is true. So, moving ahead with the next one, in the above problem, for the same problem, find the magnitude of the displacement of the queen from the front edge to the hole. So, where is the front edge? Here your front edge is. Yeah. So, this must be your front edge. From the front edge to where you have to find out magnitude of the displacement of the queen from the front edge to the hole. So, hole is here. So, from here to here, you have to find out this particular displacement. This, yes. So, following the similar procedure as the above case. So, how to find out, children? The value of S is equals to the complete. In order to get this total displacement vector, you have to consider this right angle triangle. Again, applying Pythagoras theorem here. S is equals to root over root over sum of the squares of the remaining two sides. How much is that? This portion is 2 minus x whole square plus this portion is 4 square. That's it, children. Or S is equals to 2 minus, what is the value of x? 2 by 3. So, 2 minus 2 by 3 whole square plus 4 square is found to be 16. So, this is 3, 2, 6 minus 2 is 4. 4 upon 3 whole square plus 16. So, S is equals to 4 square is found to be 16 upon 9 plus 16. Taking 16 as common, we have root over 16 is 4 times of, taking LCM 1 by 9 plus 1, we have 10 upon 9. So, square root of 9 is 3. So, 4 by 3 root 10. So, what is the correct option? 4 by 3 root 10 feet. So, let us check it out. 4 by 3 root 10 feet. So, second option have 4 by 3 root 10. But here the question is not finished, children. You are also asked to find out the displacement of the queen from the center to the hole. From the center to the hole is this portion. This also you are asked to find out. 2 questions at a time you are asked to find out. Okay. So, this also you are asked to find out. The smallest, we found the smallest value as 4 by 3 root 10, whereas this displacement from center to this portion, directly we can calculate, children. In order to find out this displacement vector, consider this right angle triangle. From the figure, the value of S is equals to right angle triangle, applying Pythagoras theorem, root over side square plus side square. What is this portion? Total is 4, this portion is 2. That is 2 square plus again this also total is 4, this portion is again 2 square. So this is equals to root over 4 plus 4. Root over 2 square is 4 and again 2 square is 4. So this is equals to taking 4 as common, you will be getting root 2. Root over 4 is 2. So 2 root 2. So displacement from here to here is only 2 root 2. So therefore the correct option is 2 root 2 feet for this, whereas 4 by 3 root 10 for the first case. So 2 cases we have considered. So only correct option is option 2. Okay children, I hope the carom board concept is clear. So 3 different displacements were asked in 2 different questions. First question, they are asked to find out only this particular displacement. So after finding out the x, consider this right angle triangle to find out the value of s. Second case, they asked to find out from the front edge to the hole, and third case they asked from the center to the hole. So 3 cases was covered. Moving to the 11th question, children, it's all about a mosquito. A mosquito net over a 7 feet cross 4 feet bed. So there is a bed. So on this bed, we have a mosquito net. So we know that something like it may take something like a cuboid shape. So the net may take something of this shape, children. And you have a bed down way. A bed is there. On this bed, a mosquito net is there. 7 feet across 4 feet bed. So that means the length of the bed is given as 7 feet. From here to here, the total length is 7. So this must also be 7 feet. Everywhere, the horizontal distance is 7 feet. And this portion, it is 4 feet. This side, this is if here it happens to be 7 and here it happens to be 4 feet. And it is 3 feet high. The height was given as 3 feet. From here to here, the height is given as 3 feet. The net has a hole at one corner of the bed. Somewhere here it has a hole. Some hole is there. Because at the bed, it was given at the bed, hole is there, not at the top bed, hole is there. Through which a mosquito enters the net, it flies and sits at the diagonally opposite. So a mosquito has entered inside, and this mosquito, after going inside, okay, so travel, something like this, and again settle down at some corner, diagonally opposite. That corner means it must come this corner, opposite corners. Out here, it entered the rarer side, and here it settled down at the forward side, okay, near side and rarer side. It flies and sits diagonally opposite upper corner, not exactly same, opposite. One diagonal here, the other diagonal at the up. The magnitude of the displacement of the vector is, you are asked to find out the magnitude of the displacement vector from here to here. So, it has moved a distance of x-axis, say something like length it covered, because from this corner to this corner, 7 feet it has covered, and that edge of the bed to this forward edge of the bed, it has also covered 4 feet, and it entered down at the bottom and now it reached up, so it also covered height. So 3, it traveled along x-axis, y-axis as well as z-axis, 3-dimensional. Hence, the magnitude of the displacement will equals to root over x square plus y square plus z square, all the 3. So, what is x? Along x-axis, horizontal axis, it covers about 7 feet. Y-axis means lengthwise, let us consider it as 4. And vertical way, some like 3. So, 3-dimensional motion. This is nothing but 49 plus 16 plus 9 under root. So, how much is that? 49 plus 16 plus 9 is 50 plus 25, 75, 74. How much is that? 74 feet, under root 74 feet. That's it. So, 3-dimensional motion, x, y, z, all the 3 categories it has covered. So, answer is root over 7 square plus 4 square plus 3 square is found to be root over 74 feet. So, let us move to the next problem. In the above problem, for the same mosquito net problem, find the magnitude of the displacement of the mosquito taking the hole as the origin. So, this they considered it as origin 0, 0. Length of the bed as the x-axis. So, what we have considered, no, x, y, z as. So, x itself, what we consider, the same they gave. X they're asked to consider as itself as a length. Width means, width, W or B, length into breadth into height. Width, let me name it as some B. And width of the side as y-axis they asked us to consider. And how much is the width they gave? 4 feet. And vertically up, 3 feet height as C. Vertically up as the some height H. Z. Height, vertical height H, they asked us to consider it as Z and it was given as 3 feet. So, 7, 4, 3, x, y, z are given as 7, 4, 3 feet. Write the components of the displacement. These are the components of the displacement vector. X component, Y component, Z component is given as 7 feet, 4 feet and 3 feet respectively. So, where is the correct option? Here goes your correct option, 7 feet, 4 feet, 3 feet general. So, this is what we have already considered in the previous problem. So, this makes it easier. So, now moving to the 13th question, children. A body covers an arc of a circle of radius r. Circle is there. Some portion of the arc it has covered, subtending an angle of 120 degrees. So, let us check it out. Circle is there. For this circle, this body covers only an arc of the circle. Earlier it was here, not 90 degrees, not 180 degrees, something in between, something like this. So, this arc is 120 degrees. A body covers an arc of a circle of radius r, subtending an angle 120 degrees at the circle. The magnitude of the displacement of the body is. Children, the displacement vector is given as something like this. Displacement vector is given as something like this. So, clearly, let me mark this instead of R, let me mark this as A, this as B and this as C. So, vector resolution, we know that vector 1, vector 2 and vector 3, if it was given A, B, C, we know that A bar plus B bar must be equals to C bar. A bar plus B bar equals to C bar, vectors la. If A bar is equals to, A bar plus B bar equals to C bar, then B bar is equals to C bar minus A bar. So, this from the concept of vectors. So, what we do is B bar equals to C bar minus A bar, or magnitude of B bar is equals to root over C square plus A square minus 2CA cos theta. From vector law of addition, if 3 vectors are given as shown, then sum of the 2 vectors taken in one particular direction is equals to the other vector taken in the opposite direction. So, A bar plus B bar is equals to C bar, or C bar is equals to sorry, B bar is equals to C bar minus A bar. So magnitude of B bar is equals to root over C square plus A square minus 2CA cos theta. Substituting given values, so from here to here it indicates the radius of the given circle. So here to here C also indicates center to this position, C is also equals to R. And B is the displacement vector, say S bar. And you are asked to find out the magnitude of the displacement vector S bar. Okay, that is what is being given. So find it out. Instead of B, what I replace is S bar is equals to magnitude of S bar is equals to root over. Instead of C, what I have to consider? R. So C square means R square. A is taken as R, so R square minus 2. C is R. R is A is again R, and cos angle between the two vectors, angle between C and A, angle between C and A is given as 120 degrees. That's it, children. So simplify this to get the value of the magnitude of the displacement vector. R square plus R square is 2R square minus R into R is R square. So minus 2R square. Cos 120 can be written as cos 180 minus theta. What is cos 180 minus theta? Here is 120 degrees. Cos 180 minus 120 belongs to 180 minus theta belongs to second quadrant. In second quadrant, cos is negative. Okay, so cos 180 minus 120 can be written as minus cos theta. Here theta is 120 minus cos 120. Therefore, the magnitude of the displacement vector is found to be root over 2R square minus 2R square times of minus cos 120. Sorry, this is cos 120 is written as 180 minus 60. 180 minus 60 is 120. So this must be cos 60 degrees. That's it. 2R square minus 2R square, 180 minus 60, 120, cos 180 minus theta, second quadrant, it is equals to minus cos theta, hence minus cos 60. What is the value of cos 60? It's 1 by 2. So minus cos 60 means minus 1 by 2. So simplifying further, we'll get, so finally we get the displacement vector as root over 2R square minus and minus will become plus 2R square and cos 60 is 1 by 2. Cos 60 is 1 by 2. This 2 and this 2 gets cancelled. So magnitude of the displacement vector is root over 2R square plus R square is found to be 3R square. Taking the square root, root over 3 is root 3 itself. Root over R square is R. Hence the correct option is R root 3. So displacement vector is given as R root 3 and hence the correct option is option 1. I hope the concept is clear, my children. Okay, so now let us move to the next one, that is last question, 14th question. A man travels 30 meters due north, 20 meters east and 30 root 2 meters due southwest. Children, root 2 indicates that a portion of angle on south and some portion is along the west, southwest, 45 degrees here and 45 degrees here. First of all, visualize the diagram. So person is there, a man travels 30 meters due north. First case, he travels north direction. Second case, due east. East means in this direction. And third case, 30 root 2 due southwest. This is south and this is west. So southwest means something like this. So this is the condition. 30 root 2 if it was given means it must be 30, 40, cos 45, some theta I'll consider. Theta must be 45 degrees. 30 root 2 cos 45 and 30 root 2 cos 45. So here it is 30 and here it is also 30. So finally, your picture will be something like this. Here is 30 meters. Here north is 30 meters. East is 20 meters. 30 root 2 southwest indicates, itself indicates 30 west and 30 south. So this is the condition. So based on that, let us try to find out the displacement vector, which is equals to 30 meter due north. North means upward, indicated by plus j cap. 20 meters east. East means 20 meter east, indicated by I cap. 30 root 2. 30 root 2 indicates that if southwest means 45 degrees here and 45 degrees there. So this is 30 root 2 cos 45 and here it is 30 root 2 sin 45. What is the value of 30 root 2 cos 45? Cos 45 is 1 by root 2. So here it is 30 meters towards which direction? West. 30 meters towards west. Hence, 30 meters towards west is written as 30 meters west, indicated by minus I cap. Similarly, it also covers some portion along south direction, that is 30 root 2 sin 45. This is equals to 30 root 2 into sin 45 is 1 by root 2, gets cancelled. This is 30 meters towards south. 30 meters towards south indicates 30 minus j cap. 30 minus j cap. This is how this 30 root 2 can be resolved into its component vectors. So if it happens to be 30 root 2 southwest means portion 30 here and 30 here. 30 cos 45 there and 30 cos sin 45 here. So like that you got it as 30 and 30 towards west as well as south. So let us simplify this carefully. So this is only displacement vector. So this after simplification can be written 30 j cap plus 20 I cap plus and minus minus 30 I cap plus and minus minus 30 j cap. So this 30 j cap and minus 30 j cap gets cancelled. Therefore, the value of the displacement vector is equals to 20 I cap and minus 30 I cap is plus 20 minus 30 is minus 10 I cap, or this can be written as 10 times of minus I cap. So this clearly indicates that the magnitude of the displacement vector is 10 meters. Minus I cap indicates it is indicating towards west direction. 10 meters towards west. Therefore, the correct option is option 1. Hence, goes with the first one. Okay, so with this we have concluded with the exercise 1A children. Let us move to the next exercise.